Hi and welcome to another Octagon Space Ecotourism video. In this video we are going to take off the support of the knuckle that came off that was in the printer in the previous video. Also going to just go through and put together the first finger. I really like the tree support. I'm a big fan. Basically, I use my Mac to do the slicing, and there's basically two versions of them. And on my other login for the other Mac, I think the tree view setting is like, this is like two lines wide, and that made it very difficult. So the fact that on this one, this is only one run thick, basically makes it a hell of a lot easier to remove, which is good. So if you look at 3D printing, you're going to see benchies. This is a very slightly inclined surface by only 1 degree, and it has this artifact, and that has to do with the fact that this whole thing has angles in it. So this is kind of one of the first things I've experimented with non-orthogonal angles. One of the cool things with Octagon is that obviously most of it are just going to be boxes, so we're not going to have to deal with this, but you know, learning how to work with that was pretty good. I can afford to be pretty rough because this is a pretty robust piece. But that being said, I can try to yank on this as much as I want. Sometimes it's not going to come across because the tree has grown into some of these little holes here, and the most sensitive parts are these little pins that are designed to clip in. Hopefully they won't stab my hand to the point of making me want to cut them off. And you can see the density gets to be pretty high, close to the top, so it has an interesting effect. Just clipping through to get rid of the bottom. So you can see here, you know, these little tree branches, kind of cool, and that's just to give this a flat surface. That basically results in this surface over here. So at the beginning of the print, the G-code software, for whatever reason, and even the Ender 3 printer has default temperatures of 260, whereas my PLA actually should print the minimum temperature of 205 and maybe it's 80, but anyways, I need to increase this. So this phenomenon over here in the G-code file, it actually is set to 60 and 200. So at some point in time when it loads, it actually went to 60. So when I start a print, I automatically go preheat PLA, which the Ender 3, if you turn it off and turn it on, I've tried saving the settings. It basically starts up again at 260, so I manually control it, putting it to 210 and 80. I do it religiously on every print. But if the G-code file says something else, at some point in time, the printer looks at it and changes the temperature on you, and that's what happened here. And I detected it, after it was too late. So always a good idea to basically watch the first couple of layers come in. So I've seen fan speeds go on and off on the first layers. I don't know if it's supposed to have the fan off for the first couple of layers, but I just always have it on. So again, lots of YouTube videos, lots of settings on the slicer. Some of the better advice I've gotten in YouTube is, a lot of the guys that are professional, they actually just use the default settings that are in the slicer. and I recommend doing the same. I'm going to try to liberate the first knuckle here by just pushing things through. It's always a good idea to turn a gap, because when you're trying to pull this away, you want to give this something to fall into. But from the tree structure, you can see that there's still a trunk there that is solid all the way through. But once again, I'm going to snap a little branch here. It's supporting that little holder. Sometimes with support, it's just best to just wedge this in there, because this is a low, this is thick, surface thickness is the same, so I got the same thing going on. So the main value of the tree is that you're going to see when we look at the surface underneath, kind of like this, it's pretty clean. But if we get, if you have support that starts off on the side where the support sits there with gravity, it actually really, really damages the surface. So right now this surface is going to be as nice as that, because the tree makes it so that there's no support touching this ledge unless absolutely required. So I'm going to keep working this. Now in the previous video I talked about, not to come up with some better terminology, I'm sure there's in mechanical engineering for these mechanisms, there's proper terms that I don't know. But as per the previous video where I'm showing the way the finger kind of slides about, the groove is on the finger part. Coming back to this piece over here, just to tie in my explanation here. I think in the flooring industry they call it tongue and groove, when you connect things like the laminate floor, with actual pieces of wood. So if that's the case, then we've got the groove, which is obviously the hole, and then the dimple or whatever, the rail as I also call it, you can call that the tongue. But effectively we've got the groove here. So when I'm taking out the support, I gotta be careful, because the tongue is actually sitting here sticking out. Now I have a broom and a dustpan in the background. Okay, try freeing up the other knuckle here. Once again, the idea is to create a gap so that the top part can collapse into it. Hey, I'm gonna end the video because I'm working on the second finger of the third one of everything, but as we can see, you know, this piece here is just this piece here and 4 of them. So again, I'm just trying to, you know, get some fitting right. I've already done a few adjustments to basically improve on the design. But yeah, 1, 2, 3, 4 fingers. Okay, so time's gone by, and basically, I wanna be filming for the, I guess the closest to the unboxing that there is. So here there's a piece of support that's actually like on the bed or on the part. Again, it's printed this way. So all the support comes in underneath. Now we got this benchy, I don't know, kind of surface over here, which there's going to be enough friction. And you can see over here, this is the part that's actually that was plain or more planar. So there's 2 angles here, and you can see that the glove, there's actually an angle relative to the center finger, this finger over here. We have an angle of 2 degrees in this way. This one here is a total of 4, so it's 2 degrees relative to that one, and then that one there is 2 degrees relative to this one. So that gives us a bit of an angle. And although there's still a lot of support to clean up, you know, and some cleanup work, you know, the big discovery with this is, and this is the first time I do this, so I'm actually pretty excited after waiting 20 hours to print, and I don't know, this is probably, maybe in the design files I'm at version 8 or whatever, but I think in terms of printing, you know, other than printing little pieces like this is like the 4th time I print this. So this is V4. And again, the difference between this version and the last version, again, the video from my nephew, is that I was actually angling the fingers away from each other in this plane, 4 degrees, and this one here, it's a total of 8. So again, that's why if this one is flush, you can see, you know, I've got a turtle. The difference between here and here is 8. So the difference between this one and this one is 16. And then after that, this is 24 degrees from end to end. Now the idea of that, again, this is way wider than my hand. I've already measured it out, and I was, you know, debating whether to print this off or not because I know that it's too wide. But effectively, you know, this distance here is quite small, but if I spread my fingers, you know, to the first knuckle, that to that is actually pretty wide. Now, when I grip, you know, with my fingers wide open like that, that's the only way that I can make room for those 8 mils. So anyways, the big unveiling is me putting my hand in here and seeing exactly, you know, how the angles are. And once again, I can tell that I still will have to do quite a bit more. So what happened with the last one is that it's kind of like, you know, I can make this work for 1 finger, maybe 2, but you can see that I still have, my baby finger is way off. So I'm gonna have all kinds of problems over here. Now, another one of the important parts of the fit is to see how, you know, when I stick this in as far in as I can, is to see how these things sit in the bottom of the ridges, and that affects a number of things, including, you know, how far in this comes in. This is the big contentious area over here. So for me, the first piece that I want to do is fit it in, obviously, with my famous thumb over this way. And I know that this distance is going to be too much, but overall, what I'm trying to get an understanding of is, so this angle here is designed to work, you know, it's 15 degrees off the long axis of my arm. And you can see here, I'm way off, right? I got a lot of work to do, which I already knew. But theoretically, you know, if I want to be, I could actually sit that underneath this way. And again, I'm getting that same overlap as I was describing before. So very quickly, and you can tell you're a prototype because things aren't gonna work all that well. But this is all the kind of the fitting, you know. There's a lot of things I wish I could design it all, print it once, and that's fine. But in a lot of cases, that is not possible. But anyway, this is the closest I've got from the end, and you can see I'm one finger off. So obviously I'm gonna have to increase the angles quite a bit as the big learning already. I still have a lot of support to clean up on these surfaces over here. But what I'm gonna do right now is slide in, you know, I even gotta clean up the support on here. This piece I printed for a number of different reasons. I obviously have to solve this hole, which I can do by stretching this guy out, or ending this hole a little bit sooner. I'll probably do a combination of both. That was a problem in the previous version. But while we're sitting here, I'm gonna basically try to fit this finger already in here, and I know that it's gonna be rough because what I do want to use this for, I can still seat my individual fingers and test them out even if I know that the angle is wrong. So I can just take 2 fingers at a time, 2 fingers at a time. So again, I'm gonna have to increase the angles, you know, you're gonna have to exaggerate them considerably. And the other thing I was thinking about to solve this gap, you know, if I look at my finger over here to the base of my wrist, I try to long up this middle finger to my long axis. You know, right now these first 2 are flush with each other, which obviously is a mistake. So I can raise these 2, or I can drop this guy. And I think I'm gonna opt to drop that guy. But definitely the angles are gonna have to change. But my fit, you know, seat is pretty good. And I want to use this to build up my fingers so that I can actually start to do them independently. And if I look at the angles, you know, when I grip like this, my index finger goes out quite a bit and my pinky finger goes out quite a bit. And, you know, there's actually quite a bit of angles there, but what happens is that the fingertips come close together and I want to be able to grip. You know, the more I angle these fingers in, the closer the plastic fingers are going to touch with each other. So I'm trying to avoid increasing this angle. But I'll definitely have to do it. I'll probably double up on all the angles. I'm going to go 8 to 16, you know, so it'll go 16 to 32, 32 to 48, and 48 to 64. So, and we'll see if we can do that. But in the meantime, we'll build this up as much as we can. The other tolerance that I have is obviously under here. You know, that tolerance is not too bad, depending on how the back of the hand fits. So I'm validating. I'll keep running the video a little longer to try to fit this in. When I try to pull these things apart, you know, as I increase these things, if we look at very close up, we can see that it goes in, it's like a roof. It goes up this way and then down that way. And there's actually a center plane. So when I cut the individual fingers, I have them all individual in CAD. And then I take the angle. So this is relative to the center finger, 8 degrees. And the middle plane is actually orientated 4 degrees. And then I gotta match them up. And then make sure that there's no gaps so that the press prints properly with no problems. But rather than keep talking, let's see if we can get the finger in and hopefully I don't break anything. And what has happened in the past is it broke over here, and it could very well be that the design is going to have to be cut so that there's a space here so that these things can be free floating. So not scheduled, I'm not planning on doing a lot more on this. Like all prints, the first time through, things were very stiff, both in the fix, but once you pop the fingers on once or twice, things will actually be a bit easier. Again, we're looking for some pops. There we go. And again, the beginning, this is a lot smoother than what I thought it would be. Curtain's not going to go through because it's support material. But now we're go that way. And we can see here, is my wrap good? It's not too bad. So the part that actually comes in on the sleeve is going to be on the thumb part. But right now, other than the angles, again, just with repeated use, this support in here is all dirty. Shouldn't be using the piece to clean it out, but I'm surprised it actually slides that well. And the nice part about it is, even with these, the tolerances are still good so that the finger slides nice and freely. So as we print along, I'm going to basically print the first knuckle of every one. And most likely, at some point in time when I come to print this the next time, again, I'll double up the angles. Hopefully I'll be able to see, when the fingers come in. I'm gonna have to fix that. The other finger is gonna crash in on it. There's my other piece here. Here it is here. So when this finger slides in, they're gonna collide, and it's gonna limit the amount of grip. So I've already tried to make the last part of the finger thinner, right? You can see that these two touch each other, but there's still a gap, so that they'll meet this way. But I'm gonna run, that's not a lot of that doesn't give me a big allowance. So I can theoretically calculate all the angles and all that kind of stuff, but it's a trade-off from one to the other. So at this point in time, I'm limited by the curtain, making sure that I really have to take that first angle out. So this has got to drop, or this finger's got to come up. One way or the other, it adds up to be the same. But anyways, still needs a fair amount of work. So the last part is I'm going to take, because this finger is the same size as this guy, and because this guy here, this first joint, this piece over here, is too long for my index finger, I can stick it in here and give that a go. So let's do that. And then we'll call it a video. You can see now I'm trying to stretch this, and as we go along, this guy here, they're getting thicker and thicker as I move the angle, and that gives me less flexibility to pull this apart and snap the fingers in. So like the last time, for sure, snapping the finger out is going to be hard. I'm going to do like I did before, put the spatula in. And just because I can get it in, it doesn't mean that I can get it out. Stretching it out a little bit, trying to get. I'm off camera because I'm using my leg to push it off against. Should have done this before. Start scraping off the support. Generally speaking, if you got sliding parts, you just rub them against each other and the support will wear off. But there's a limit to even that. So in later videos, when I do better fits, we're gonna see, it'll be nice and smooth because all the little support pieces are worn out. So this is just the rough first motions. But overall, here we go. Got ourselves a finger that can double over, and we'll leave you with this as the final message.